Hi class, today we are going to be in our volume packet and we are going to be looking at the volume of a sphere. So if you recall, we did the volume of a cylinder, volume of a cone, and today we're going to do a volume of a sphere. So turn to page 9 in your packet. Okay, on page 9, before we get started with the actual notes, I just wanted to play a couple of videos from a Desmos that we're not going to do the Desmos today, but there were some really great videos to demonstrate the properties of volume of cylinders, cones, and spheres. So notice in this first video here, we have a cylinder on the right and a cone on the left. And notice that both bases are circles. So notice that in the formula, both of the formulas, we have an area of a circle for their base and times a height. And then it asks, how many cones do you think would fill a cylinder? Which we talked about that in the notes, so hopefully you're able to answer that from the other day's notes. Oops. I'm going to play this video for you. He's filling up the water fully one time. Two times. And 3 full times. So notice that is why in our formula of a cone, we take the cylinder and divide by 3. So the next video we have is a sphere, right? Think about your ball, a sphere. And there's your cone. And he's pointing out in the video that it has the same height, right? And if we cut a sphere in half, we get that cross section of a circle. So take a guess, maybe hold up your finger so everyone can see how many cones would fill a sphere. Okay, let's see if you're right. Thought I pushed play here. All right, let me try that one more time. Okay, some technical difficulties, but we've got it. So he's just setting it up so that he can fill the cone with the water, or and then fill the sphere. And he's just going to transfer it to this cup on the right here, the triangular prism, because of it has a easier spout to pour, but it's the same water. So notice that the cone filled up halfway the sphere, filling the cone up again, putting it into that next container to make it easier to pour. And notice that it is filling up right to the tippy top, minus a couple drops maybe here or there. And it's filled. So it took 2 cones to fill the sphere. So if you guessed that, you're correct. And then I just like this because it kind of goes through the formulas here. We have the formula of a cylinder, right? The area of the base of the circle times the height. Then we have the cone. We said that if we take a cone and fill it, it'll fill the cylinder. If we fill that cone 3 times, it'll fill the cylinder. So a cone is 1/3 what a cylinder is. And then a sphere, if we think about it having the same radius, all these objects were at the same radius, same height. It took 2 of the cones to fill the sphere. And if you think about 2 of these, this is kind of how we get the formula for a sphere. So the radius and the height is twice the radius there. So if we think about this radius, it's going to be 2 of those radius to make that height. So that's why in our formula of a sphere, it's radius cubed instead of radius squared. And we're multiplying by 4/3. Okay, 4/3 radius cubed pi is our formula for a sphere. The great thing, though, about 8th grade is you don't have to necessarily understand how the formulas are derived. You only have to know how to use them. And remember, you do not have to memorize them either. So now we are going to actually use those formulas to find the volume of a sphere. So in number 1, obviously we have a sphere here. We have a radius of 10 miles. So a huge radius here. 4/3 pi r cubed. Now I'm going to show you writing it both ways here. You might see it written this way, or you might see it written this way as well. So either one, and I'll talk about times when you might want one versus the other when we talk about determining lengths. So this one is, we're going to do 4/3 pi. The radius is 10, and that's going to be cubed. So that's 4/3 times pi times 1,000. Now, when we do 4/3 of 1,000, we're not going to come out with an even number when we divide that, right? It's going to be a 0.3 repeating. So what we can do is we can multiply the 4 times 1,000 to have 4,000, keep the denominator of 3 pi miles cubed. Or if you did it on your calculator, you'll get 1,333 and 1/3, because 0.3 repeating is 1/3, pi miles cubed. Now, I think it's much easier to keep it like this and just check to see if it divides evenly. If it doesn't divide evenly, multiply the 4 times whatever the radius cubed is, and then keep 3 as the denominator. That's a perfectly acceptable answer. And that's what I generally use for the answer key in the formative. Now, if it tells us to round to the nearest tenths, I can either put this or this in my calculator times pi, and you should be getting this in your calculator. So stop the video, try to see if you can get the exact volume times pi, put in the pi symbol, and see if you can get this amount. And round it to the nearest tenths. That would be 4,188 and 8/10 cubic miles. And don't forget, when you do the formative, I generally put my units like this. So if it's inches cubed, centimeters cubed, I just raised it to the 3rd power by doing shift 6 and then the 3. So that would be easier for you. And I don't think I put commas in the answers, but sometimes I might have added like 3 or 4 answers, and I might have had the comma for the separating the 4,000. Okay, so if you need help, stop the video and see if you can do that one. In this next example, notice that the 16 inches is a diameter. So we have to have half the diameter is the radius. So the radius is going to be 8 inches. So I have the volume of a sphere written this way. And it doesn't really matter which way you put it. So radius is 8, so I'm going to cube that, divided by 3. So 8 cubed would be 512 divided by 3. And again, when you do this, it doesn't come out to be just an integer. So I can multiply 512 times 4 to get 2048 divided by 3 pi, and this is cubic inches. Or if you divide it, you're going to get 682 and 2/3 pi inches cubed. So either or for your answer is acceptable. And then when you put that in your calculator, go ahead and put that in your calculator. And this is the number you should be getting in your calculator screen for the rounded amount. If we round to the nearest hundredths place, this 6 is in the hundredths place. We look to the 0. So 2,144 and 66 hundredths cubic inches is our rounded volume. Okay. And remember, if this video is going too fast, you can always rewatch it on your own or go and look at the copy of notes as well that are posted in the calendar. On the next page, we have a lollipop shaped like a sphere and a radius of 12 millimeters. Find the exact volume of the lollipop. So why don't you pause the video and try this example, and maybe try the next example too with the ball. And then we'll play the video and see how you did. Okay, we have a sphere, so I'm going to write the formula for a sphere. Oops, that's a 3. And the radius is 12, so I'm going to cube that. And 12 cubed is going to be 1,728. So when I take 4/3 of that, I'm going to get volume equals 2,304 pi millimeters cubed. Remember exact because pi is in our formula. Oh, you can. Okay. Now we have a ball shaped like a sphere. Volume equals 4/3 pi r cubed. We have a radius of 15, so that's the number that I am going to cube. And when I cube 15, I get 3,375 and multiply that by 4/3, and I'm getting 4,500 pi, which if I look at the closest, when I do that in my calculator, I'm getting 14,137.16694. So the closest amount would be this amount there for letter B. Okay, the last example that we're going to do today is talking about a hemisphere. So obviously a hemisphere is half of a sphere. So there's a couple of ways you could do this problem. One way is right when you talk about the volume of a sphere, you can take half of that. And another way is you could find the volume of the sphere and then take your final answer and take half of that as well. So either one is acceptable. I like to just put the half in the formula for the hemisphere so I don't forget to do it at the end. So obviously it gave us the diameter. We're going to use the radius. So volume is 1/2 4/3 pi, and then this is here. And of course, if you think about multiplying a half and 4/3, you'd get 4/6, which is 2/3, right? So some of you might say, oh, I could just do volume equals 2/3 pi r cubed for hemisphere as well. So that would work. Like I said, there's lots of different strategies. So when I take half and 4/3, when I cube 24, I get 13,824. And then when I multiply those and take half, I'm going to get a volume of 9,216 pi meters cubed. Again, it says leave in terms of pi, so that is my exact volume. Okay, so after this, you're going to do the formula on spheres. Don't forget to put your units cubed. And if it needs pi, make sure pi is part of your answer. If you have any questions, please come see me during Flex.